Hi guys, welcome to our channel, The Tutor. In this video, we are going to start with electrochemistry. The completion of this chapter will give you an idea of how a battery is getting charged as well as how is it getting discharged. And also get to know about the chemicals used and the chemical reaction taking inside a battery. In that, first we will start with types of electrochemical cells. There are two cells. One is galvanic cell and the other one is electrolytic cell. First we will talk about galvanic cell. It is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into chemical energy. We can encounter many examples for galvanic cell in our day-to-day life. Few examples are the batteries which we use for our wall clock, and the one which we use for watch is also a galvanic cell. And the second one is electrolytic cell. It is an electrochemical cell that brings about non-spontaneous redox reaction in the external voltage. This is not the exact definition from NCERT because they didn't give it very clearly, so I made up this definition for your better understanding. And the example for this is charging of a battery. After knowing the definition of galvanic cell and electrolytic cell, let us try to understand how a battery works, how is it getting charged as well as discharged. As we know from our lower classes, the more reactive metal will displace the less reactive metal. That is called spontaneous reaction, that is, it will happen on its own. Del G, that is Gibbs function, will be negative for these reactions. If you are watching this video in your mobile phone, your battery is acting as a source which is providing some electrical energy. That electrical energy is coming from the spontaneous chemical reaction taking place in your battery. So now your battery is acting as galvanic cell. And now when your battery becomes empty, you automatically put it for charging, right? And now your battery is acting as electrolytic cell because some external voltage is applied to bring about non-spontaneous reaction. For now, you just try to keep these things in your mind. After seeing the Daniel cell, I'll try to explain these with an example for your better understanding. Among the two types of cell, first we will talk in detail about galvanic cell. Daniel cell is an example of galvanic cell. Now we will see the chemical reaction taking place in Daniel cell. First we will see the half cell reaction. Copper ion is reduced to copper and zinc is oxidized to zinc ion. This is because zinc is more reactive than copper. The combination of two half cell reactions will give the full reaction. Now imagine that we are using Daniel cell as your cell phone battery. Let's try to understand that better. While using your mobile phone, your mobile battery is acting as galvanic cell, that is, it is providing energy, that is electrical energy. So zinc will displace copper ion from copper solution to give zinc ion because zinc is more reactive, which implies it is a spontaneous reaction. And at the same time, when your battery is dead, you put it for charging, right? At that time, the reverse thing happens, that is, copper displaces zinc. Now your battery will act as electrolytic cell because at some external voltage, non-spontaneous reaction is taking place. That is, copper is displacing zinc, which is non-spontaneous because copper is less reactive than zinc. Now we are going to see a trick called lone trick. In the electrochemistry, there is a convention according to IUPAC that anode will be on the left hand side. So here is a trick to remember everything by the word lone. There is expansion for every single letter. First we'll see for L. L denotes left hand side and O is for oxidation, A is for anode of cell and N is for negatively charged. If they ask any question regarding these, just write lone and its expansion. So if you want any information about cathode also, you can get it from this side because it will exactly be the opposite one. There is a formula for cell potential and it is denoted as E cell equals electric potential of the right hand electrode minus electric potential of the left electrode. Or it can be said as potential of reductive electrode minus potential of oxidative electrode. Now we will see how electrode potential is measured. First we'll see the definition for electrode potential and standard electrode potential. A potential difference develops between the electrode and the electrolyte, which is called electrode potential. And the second one is when the concentration of all the species involved in the half cell is unity, then the electrode potential is known as standard electrode potential. As we all know, potential is always relative. So here for electrode potential, we have the reference as hydrogen electrode. That is, we take hydrogen electrode to be 0, and with respect to that we calculate each and every electrode potential. So now let's try to understand how it's being done. On the left hand side or on the anode side we connect the hydrogen electrode. On the right hand side or on the cathode side we connect the electrode which we want to measure. Now according to the cell potential formula, cell potential equals ER minus EL, and E right we get the potential which we want to measure, and E left, that is on the anode side we connected hydrogen electrode, right? So it is 0 according to the reference we took. So finally we will get the electrode potential of the one which we want to measure. And coming back to the Daniell cell, we will try to calculate the cell potential of the Daniell cell. The electrode potential of copper is 0.34 volt and electrode potential of zinc is minus 0.76 volt. These values are experimentally obtained. And according to the E cell formula, we have electrode potential of right hand side minus electrode potential of left hand side, right? So after putting the value, we get the answer as 1.10 volt, that is 1.1 volt. Automatically zinc will displace copper because zinc is more reactive as we told you earlier. But if you want copper to displace zinc, you just have to need an external voltage of 1.1 volt, which will make the non-spontaneous reaction to occur. So that's all for today's video. Thank you for watching this video, and don't forget to share this video to your friend who didn't understand this topic properly. Bye.